presentation. Good morning, ladies and gentlemen. So, as our chairman said, that the title of the presentation, Plasma Unit for Processing of Carbon-Containing Waste. So, as you know from the first presentation, we usually work with coal, but waste, it is a rather different substance. But at the same time, you can see for composition of medical waste, and you can see that it contains paper, most of all, plastic, metals, wood, and other. And if we see on the next slide, we can see average ultimate analysis of medical waste, and we can see that that is not far from coal, really. A lot of coal, of course, ash, carbon, the main element, and so on. So it's not far from coal. That's why we can use our experience for processing of this stuff. And also, you know that we work with plasma. And here you can see some advantages of plasma methods for waste processing. First of all, that is complete decomposition of the waste with the formation of basic compounds that considerably simplifies the cleaning of contaminants. Possible co-processing of different types of waste without pre-sorting. A significant decrease in the volume of the gases and consequently the load of the gas cleaning system. Smaller carryover of dispersed particles, high performance with small dimensions of equipment, ability to create a desired gaseous atmosphere, so we can use after that synthetic gas, which, for example, which we can produce during utilization of the stuff. Ability to produce the final product in a stable form, and possibility of operative adjustments the process by changing the flow rate of oxidant. We use air as an oxidant and power of plasma torches. First of all, thermodynamic modeling. It can show us what we can get having high temperatures, which we usually have in plasma. So the thermodynamic modeling was produced using Terra code, and calculations were performed over a range of temperature from 400 to 4000 Kelvin and at atmosphere pressure. Here you can see composition of bone meal for processing of plasma furnace. That is one of the usual stuff in medical biological waste. And here you can see the content, and that was presented in one formula. And 4 variants we calculated. Here you can see for 10 kilogram of waste we used 1.5 kilogram of air, 3 kilogram of air, 5 kilograms of air, and 1 kilogram of air and half kilogram of water steam. The last variant can model wet waste. So that is just for the first variant. You can see figure in gaseous phase at high temperature more than 1000 Kelvin. We can see synthesis gas, so COH2, and of course nitrogen, because we use air as an oxidant. All other components have rather small concentration, and as you can see again, the main, that is a synthesis gas and nitrogen. And at high temperature in the gaseous phase, we can get some components from mineral part of waste. Most of all, here you can see on this slide. And what we have in condensed phase during the temperature increase. When we have, first of all, carbon goes to the gaseous phase, you can see by the temperature a little more than 1200 degrees. And in the condensed phase at high temperature, we just have calcium O. And here you can see specific power consumptions dependence on temperature for all four variants calculated. So I think we have to work at the lowest temperature for plasma process. It is about 1500 degrees. And at that temperature, we can get a little more than 1 kilowatt-hour per kilogram for specific power consumptions of this process. So after that, we try to construct experimental installation. Here you can see the scheme of this experimental technological installation. That is a plasma chamber. And here you can see that is a plasma torch. From that plasma torch we can get plasma flame, high temperature plasma flame, and inside of this chamber all the waste, first of all warm, after that the process of gasification goes, and after that, slag goes to the slag catcher, and the gas goes to the utilization system. Here, for example, it can be incinerated in the boiler utilizator, or it can be used for any other purpose. Here you can see layout of plasma torch, which we used for that plasma chamber. And that is a photo of this plasma torch, which power was 30 kilowatt. And for example, the flame on the outlet of the anode of this plasmatron was 5000 degrees centigrade. Or Kelvin. One more plasma torch which also was used for this chamber, that is a plasma torch Vortex 200. 200, that means it can work up to 200 kilowatt. And here you can see plasma torch layout and test photo from our laboratory, test of plasma torch. Also, the temperature of this flame is about 5000 degrees, and but this plasma torch can get much more air for plasma flame, and we have more high temperature in the volume of the chamber when we use this plasma torch. Here you can see plasma box furnace with a plasma torch of 30 kilowatt in laboratory, and that is installation for plasma torch Vortex 200. You can see that plasma chamber insulated from inside with bricks, and that is a plasma torch on the top of this installation, and the waste is going to this chamber, and as I said, after some minutes of plasma torch working, everything disappeared inside of this chamber. So parameters of plasma box furnace you can see here on this slide. For the plasma torch, which we did first experiments output power was from 50 to 35 kilowatt. And at the same time, plasma forming gas air flow was from 1 to 2 grams per second. And the geometrical dimensions of Bock furnace you can see here. And the amount of the process material can be about 10 kilogram per hour. Modes of operation, you can see here also, so the duration of the experiment, that is, when we start plasmatron, we need 5 minutes for warming up of the furnace, of the chamber. After that, we need 3 minutes for burning of organic matter, melting of inorganic matter, 7 minutes, and the total cycle, including cooling and loading of new product, is 30 minutes. Here you can see gas composition after plasma processing of biomedical waste. That is in the gaseous phase, CO, H2. So you can see that the main elements, that is again synthetic gas, CO and H2, and nitrogen, of course. And conclusion, in this plasma box furnace, the process of recycling of organic matter takes place. Waste under the influence of temperature is completely broken up to form of simple chemical compounds. The relative contents of processed product depends on the humidity and temperature of the process. Plasma recycling technology is universal. It can be used for recycling of any waste, regardless of their qualitative and quantitative composition. Develop the technology and equipment to implement the process of thermal processing of solid and packages biomedical waste is tested on real materials, animal bones. Thank you for your attention.